Okay, in this video we're going to explain how we set up Grasshopper and Revit in order to make our final form. So this is our final pavilion here, which has this adaptive panel which changes its opening aperture according to a daylight factor. And also there's another element down here which forms the structure of the whole pavilion. But before going into Revit and the components, we should first set up in Rhino and in Grasshopper a logic that allows us to host elements in the Revit environment. We know that our shading panel and element is a quad panel, so here we did some list management to get the 4 corner points of a mesh face, but then we also want the center point of the mesh face in order to get a more stable normal for the panels. For the structure, it's actually when you look at it, it's actually just like a beam, but it's going in cross direction. So in Grasshopper here, we're trying to get point 1 to point 3 and then point 2 to point 4. So this sets up the logic for hosting the structural elements. Okay, right now I'm going to show you how this how this component works. This component takes the parameter P0 from the daylight measurement, and then as this gets smaller, it gets flatter and more opaque. When it gets larger, it gets the openings are larger, and also it gets higher or taller. And so the way to build this is to first open up a family, generic model adaptive, and first construct 5 points. Make these adaptive points. And one important thing to do here is to make the middle point, which is point 5, orthogonal in family, so that as it's applied into the project file or into the surface, it keeps its normal. So now we should make some reference lines from each of the corner points to the center point. Oh, before we do this, we should set the work plane to 0.5. Okay, so right now, draw these reference lines. Remember to turn on 3D snapping. And then meet a point in the center as the offset. We could we should make a parameter for this point, call it offset. Okay. For now, just give it a random value. But the way we're going to drive this point is to take measurement from the corner points, make this a reporting parameter, say, okay, so that it reports the distance from corner to corner, which is diagonal. And from here you could make a number parameter, call this P0. So this establishes the relationship between the Revit model and also the diva information. Right now, just give it random value, and then here enter using P0 to drive this offset, and this might be too big, so you should give it some kind of division. Okay, go back to this work plane, and then straightforward stuff. Just connect all these points to this offset point. And then make a point on each of these bottom curves. Select these points. Oops. Select them. And give them parameter which is P0. Okay, so right now these openings or these points on curves are driven by the diva information as well as this center point here. And then go back to this reference plane and draw more lines, connect these two. At this point, we could test some, stretch it, see if it breaks. So try to stretch this one. Looks pretty okay. So last step would be to make surfaces. Create form. Do this several times until you're done. Here you go. So try to vary this, see if it changes. Okay, you could see like when it approaches 0, it tends to get too flat, or when it approaches 1, it would tend to get too narrow. So to solve this problem, we could do this little trick in Grasshopper, which is to remap the values to 0.2 and as the minimum value and 0.8 as the maximum value, so that the geometry in Revit, so that this P0 never gets bigger than 0.8 or gets smaller than 0.2. Right. Lastly, let's open a new project and try if this works. Load this, project 1. P0, okay. So it works. And the structural component is in fact just 2 points, a profile and an extrusion. So it should be straightforward. And I guess that's it.